Okay, now the next question we're going to do is on substitution. And this is where we can start to use it for problem solving. And this is the traditional part where students start to think, oh, this is very hard. But let's see if we can break it down to something that's relatively easy. So, to use algebra for problem solving requires replacing unknowns with variables. So if we don't know something, we're going to put a variable in its place, and substituting where necessary. So when we say substituting is where we have a variable, we're going to put a number or a quantity. So here's a problem, and that might help you put all those words into the right places. Mary's having a party with boys and girls. At the end of the party, she gives the boys and girls a gift. If she has X boys and Y girls, so she doesn't know how many boys there are, but it's just some number X, and doesn't know how many girls she's got, that's just some number Y. How many boys and girls are invited to the party? So, total number of people that are at the party would be the number of boys, which is X, from this bit here that's underlined green, and also this part Y for the number of girls. And if we added those two together, we will get the total number of boys and girls. Now, on the day, according to this, 23 boys and 15 girls attended. So X would be 23 and Y would be 15, because earlier we said there were X boys, so that's the number of boys, and we now know that the number of boys is 23, and Y girls, and we know the number of girls is 15, so Y would be 15. So X plus Y would be 23 plus 15. So that's the total number of boys and girls that are there, for a total of 38. Now this process of putting numbers where we've got variables, so here we put 23 where X was and 15 where Y was, is called substituting or substitution. So when we substitute a number for a variable, we're doing substitution. Now over here we'll take that one step further, and now we'll get to the problem solving aspect, not just substituting numbers for variables. Each boy is given a gift bag with a car and 2 lollipops. Each girl is given 2 cars and 1 lollipop. Given the information in part B, so we know there's that many boys and that many girls. In part B, that many boys and that many girls. How many cars and lollipops do we need altogether? Now, here's where we have to be a little bit careful. We know that there's X boys and Y girls, and we know that for cars, let's see, a boy gets a car and a girl gets 2 cars. So we're going to need a car for each boy and 2 cars for each girl. So let's see what that looks like in numbers. There are 23 boys and they get 1 car each. And there are 15 girls and they get 2 cars each. So that'll give us a total of 23 plus 30, which will equal 53 cars needed. Now let's look at lollipops. Each boy gets 2 lollipops and each girl gets 1 lollipop. So we'll need twice as many lollipops for the boys as we will for the girls. So that would be 23 times 2 for the boys and 15 times 1 for the girls. 2 lollipops for each boy, 1 lollipop for each girl, which will give me 46 plus 15, which will be 5161. Now, the 3 steps: we establish the unknowns, we substitute the numbers into it, and then we evaluate the answer. Let's go into some simpler exercises. This is where we want to get to, but that might take us a bit of time, so let's have a look at some worked examples which might help us. Now remember, if you didn't get this the first time, you can always watch it a second time, and then you might get a little bit more, and then watch it maybe even the third time, and a bit more will make sense. So let's say, more simply, that x equals 3 and y equals minus 4, and we're just going to do the evaluation stage. So we have an equation. We worked out that the equation was 8xy, and we want to know if we substitute 3 and negative 4 into this equation, what will the answer be? So that will be 8 times by 3 times by negative 4. So where I have x, I've put 3. Where I've had y, I put 4. And when we've got an expression like this, we're multiplying in between. We just don't normally write it. I'll write it this time when we're evaluating, just to make my life a bit easier. And then we'll establish what the answer is going to be. Now, positive, positive, negative. One negative, odd number, the answer is going to be negative. Let's see what's the easiest way to multiply this. Maybe 8 times 3 and double them twice. So 8 3s are 24, 48, 96. I expect you to use your calculators. And there's the answer. So that's the first one. Let's do another one. Still substituting in 3 and negative 4. 4 times 2x. Take 8, take y. That will be 4 times 2 times x. 2 times 3, take 8, take negative 4. I have to be a little bit careful with this one. That'll be 4 times by 2 3s are 6, take 8 is negative 2. Negative, negative will be positive. Negative 8 plus 4 will give me negative 4. C. Well, we can do this one. It just looks complicated. 2y squared plus 5y take 3x. 2 times negative 4 squared plus 5 times 3 take 3 times 3. So that's 2 times 4 times 4 is 16. Negative times negative is positive. 5 times 3 is 15. Take 3 times 3 is 9. 32 plus 15, take 9. 47, take 9. That should be 38. Oh, there's an error in here. Let's check. Ah, this is a y. I've messed up. Start again. Did you notice that? So, 2 times y squared, that's that one. This one needs to be 5 times y, which would be negative 4. Take 3 times x, which would be 3. Let's try again. 2 times 16 is 32. Negative times negative will be positive. 5 times negative 4 is negative 20. Take 3 times 3 is 9. So that'll be 32 take 29, which will give me 3. That's D. I suppose we can do this. This one's a bit harder. 2x plus y divided by 5. Oh my goodness, what a fraction. Not that hard. So put 3 where the x is. 2 times 3 plus negative 4 where the y is, divided by 5. 2 times 3 is 6. Positive, negative together would be negative. 6 take 4 on 5, which equals 2 on 5. Perfect. Now that you've done all this, you'll be able to do questions 1, 2, 3, 4, and 5. And if you want to, you can find 6 and 7. Thanks everyone. I hope that was fun.